In the early 1990s, Dutch anthropologist Ida Sabelis and her partner volunteered for a groundbreaking MRI study on human intimacy. Researchers aimed to observe internal physiological changes during intercourse using non-invasive MRI technology. The couple's participation stemmed from both personal curiosity and professional interest in advancing sexual science. Their story began in a modern lab at the University of Groningen, where whiteboards brimmed with hypotheses about pelvic mechanics. The research team faced intense scrutiny from ethics boards who questioned the study's validity. Consent forms highlighted participants' rights, while skeptical professors debated moral implications. Sabelis later recalled how institutional resistance mirrored societal taboos around sex research. Approval finally came with strict protocols. Scans would occur during hospital downtime, ensuring no interference with medical priorities. Technicians modified the MRI's narrow tube with ergonomic padding to allow intimate contact. Emergency stop buttons were installed within reach, while motion tracking sensors calibrated for minimal interference. The team tested positioning extensively, finding the sideways spooning position most viable. Sabelis noted how clinical preparations contrasted starkly with the organic act they aimed to study. Initial attempts failed spectacularly. The MRI's 98-decibel clanging disrupted rhythm, while confined space made movement nearly impossible. Sabelis described how laughter eased tension when her partner accidentally kicked the emergency button. Researchers realized traditional positions wouldn't work. The data showed erratic physiological readings from constant adjustments. Using motion capture data, the team designed specialized positions, minimizing machine interference. The modified spooning pose reduced movement by 73%, while real-time fMRI tracked brain activity. Surprisingly, scans revealed the penis curves like a boomerang during penetration, contradicting Leonardo da Vinci's straight-line anatomical drawings from 1492. Between scans, Sabelis reflected on reconciling romance with sterile lab conditions. Brain scans showed oxytocin spikes during whispered affirmations, proving emotional connection impacted physiology. The research challenged assumptions that arousal stems purely from physical stimulation. Their prefrontal cortex activity mirrored patterns seen during deep meditation. On the 8th attempt, synchronized brain scans made history. Both participants' ventral tegmental areas, reward centers, activated simultaneously. The data proved mutual pleasure created unique neural synchronization unseen in solo arousal. Researchers celebrated as scans finally captured the elusive coupling rhythm of pelvic movements with 0.3-second precision. Analyzing 13 successful sessions revealed groundbreaking insights. Women's bladders filled rapidly during intercourse, suggesting an evolutionary urinary response to prevent UTIs. The data debunked centuries-old anatomical myths, while proving emotional intimacy amplified physical responses by 40% compared to mechanical stimulation alone. When Nature rejected the study, tabloids sensationalized it as MRI porn. Conservative groups protested outside the lab, while scientists defended its merit. Sabelis lamented how coverage ignored their discovery of synchronized neural coupling, a phenomenon later validated by Stanford's 2022 intimacy studies using next-gen fMRI technology. Though initially controversial, this pioneering study laid groundwork for modern intimacy neuroscience. Today, their findings inform therapies for sexual dysfunction and relationship counseling. Sabelis's final interview revealed pride in advancing gender equality, proving female pleasure warranted scientific scrutiny. The MRI machine remains a museum piece, commemorating when love and science became inseparable.